In this video, we will study about the Lami's theorem. Okay, the theorem is mainly related to the forces here, that to three forces, the coplanar forces. If three forces acting at a point, then what will be the statement and what will be the derivation related to that here. Okay, that is the Lami's theorem here. Okay, so this is comes under the equilibrium of the forces here. We have two forces equilibrium principle, three force equilibrium principle, and four force equilibrium principle. Okay, in two force equilibrium principle, if one force is acting, if two forces are acting at a point, the resultant of these two is exactly the opposite and collinear. It will be in collinear and it will be in opposite direction. If two forces acting at a point, then resultant these two forces should be equilibrium. Then resultant of these two forces should be two forces should be exactly in opposite direction and equal in magnitude, and it will be in collinear, in the same direction, in the same line. That is the at that time, at that condition, you can say it is the equilibrium condition. Okay, in three force equilibrium principle, if three forces acting at a point, then resultant of the two forces will be exactly equal in magnitude, and it is equal in magnitude of the third force, and it will be the opposite in direction, and it will be in collinear direction. That is the three force principle of the equilibrium principle. For the four force equilibrium principle, if four forces are acting at a point, then the resultant of the two forces is equal to the resultant of other two force, and the direction of these two will be exactly in opposite, and the force of action is in the collinear. This is how the equilibrium of forces it will be explained. The main principle of equilibrium of forces: you have two force equilibrium condition, three force equilibrium condition, and four force equilibrium condition. Now whatever we are explaining the Lami's theorem, it is three force equilibrium condition. Okay, if the three forces are in equilibrium, then what will be the condition, what will be the statement? Okay, first I'll read the statement here. It states that if three coplanar forces, you have three forces, three coplanar, it means in the same plane, coplanar forces acting at a point. For example, I'll take here P1 force, Q1 force, and R1 force. These three, they are in coplanar, it is in same plane, and they are acting at a point O here, acting at a point. Okay, B in equilibrium. If they are in equilibrium, then each force is proportional to sine of angle the other angle of other two. Okay, it means what he is saying, that if they are in equilibrium, if three forces acting at a point, they are in equilibrium, then each force is proportional to sine of angle of other two forces. It means Q divided by the angle of B is equal to P divided by angle of the sine of angle of alpha is equal to R divided by sine of angle of gamma. Okay, so mathematically how we will states here, P, this is the P force, one force, P exactly the divided by sine of the angle of other two forces. The other two forces are Q and R. In between Q R, that is the angle alpha. So P divided by sine of alpha equal to, now come to the Q force. Q is Q divided by, what are the other two forces here? P and R. The angle between P and R is beta. P and R, that is Q divided by sine of beta equal to, the other force is R. This is the R. Leave it this R. The force, other two forces are P and Q. The angle between P and Q is gamma. That is sine of gamma. This is the statement of the Lami's theorem. Okay. P divided by sine of alpha equal to Q divided by sine of beta equal to R divided by sine of gamma, where P, Q and R are the three forces. are the three forces, and alpha, beta and gamma are the angles shown in figure. You have to write exactly whatever the force you are writing divided by sine of the angle of other two forces. Equal to again one more force divided by sine of angle of the other two forces, equal to the one more force divided by sine of angle of the other two forces. So three forces. Here three forces coplanar acting at a point O, and this is the condition here. Okay. Now we'll go for the proof here. Okay. That is proof. Proof for the Lamis theorem. That is proof. First, I'll draw the forces here. This is the point, and here is one force, and here is one force, and here is one more force. Okay. This is one force, this is one force, and this is one force. This is P, and this is Q, and this is R here. This P and Q, and this is R force. Okay. So angle are alpha. This is alpha. Okay. And opposite to Q is beta. And opposite R is the gamma. This is the gamma here. Okay. As we know that, consider three coplanar forces. First point, consider three coplanar forces P, Q and R acting at point O. I'll put it this one as O, acting at point O, as shown in figure. Okay, this is the first point here. Now the second point is, let the opposite angles are, let the opposite angles to the three forces are, what are the opposite angles? Alpha, beta and gamma. That is alpha, beta and gamma. Okay. Now we'll start. What we'll do, first we have to extend the, here O, we put as this one OAB. This is O, this is force A, and this is B, and this is D. Okay, point, we'll put it as the end points. Now extend OD. For up to particular line. You have to do some construction here. Just I'll extend OD. Okay. This is gamma. Extend OD. Now what you will do, draw a line OB parallel to here AC, which meets the extended line OD at point C. Okay. You have to draw a line OB parallel to AC. Here some point it will come AC, which meets the extended line OD at point C. Okay. Just I'll extend here. Just draw a line parallel, exactly parallel to, this is the construction. One, exactly this parallel to this here. This parallel to this one. Now what next you will do? Draw a line OA parallel to BC, which meets the extended line OD at point C. Again, next line here, just this I'll mark, it will meet, and exactly this parallel to like this. Just make it this point as B, OB. Okay, and this parallel to this here. Okay, I'll mark this one as point C. We have to do some construction here. Now I'll just next point, extend OD. First you have to extend OD, right? Extend OD. Next point, draw a line with suitable scale. You have to take certain scale with suitable scale. AO parallel to BC, AO parallel to BC, which meets extended line OD, which meets extended line OD at C, at point C, at point C. Did you understood? It means you have to draw a line AO parallel to BC, AO parallel to BC, which meets the extended line, because you are extended the OD up to particular point here. Okay, it meets at point C here. Okay, similarly, what is the next point? Draw a line OB parallel to AC, which meets extended line at C. It means when you join AC and BC, the C is the point here. Okay, that is the thing here. Now can we call it as OACB is a parallelogram, right? OACB is a parallelogram. From figure, OACB is parallelogram. Right? So now we know that the parallelogram law of forces. Now apply the parallelogram law of forces. What it says, if two forces acting at a point be represented by the other two forces will be represented as the parallelogram forces here, then the resultant is the diagonal of these two forces. These two forces. Which one is the diagonal of these two forces? P and Q. This is the OC is the diagonal, and it will be acting. See, suppose P is in this direction, Q is in this direction. Similarly, in the parallelogram, it is in this direction and it is in this direction. So the resultant is acting OC. OC is also in this direction. Okay. So from parallelogram law of forces, from parallelogram law of forces, OA and OB are adjacent sides. OA and OB are adjacent sides. And resultant of two forces. And what are the two forces? P and Q. Resultant of two forces P and Q is the diagonal diagonal OC, both in magnitude and direction of parallelogram is the diagonal OC represented in both magnitude and direction. Okay, just I'll once again clear the concept here. The two forces, if two forces act, parallelogram law states that if two forces acting at a point, okay, and then you have to construct a parallelogram related to like this here, then the resultant is the diagonal of parallelogram. The diagonal of parallelogram represented in magnitude and direction. As I shown here, this is the magnitude, OC is the magnitude, and the direction is in upper side direction, in the opposite side direction. This is the resultant of these two. Now come to the next point here. As the equilibrium of forces, three forces, in the just before the beginning I explained three forces equilibrium principle, two force equilibrium principle, and four force equilibrium principle. Now this is three force equilibrium principle. Okay, what three force equilibrium principle states that if three forces acting at a point will be in a coplanar and will be in equilibrium condition, at that time the resultant of two forces will be in line with the third force, will be collinear in the third force, and it will be in the opposite direction. From the figure we can see that OD, the OC is in line with OD, and it will be in opposite direction. See here, OD is in downward direction and OC is in downward direction. So from equilibrium principle of force, principle of forces, three forces, okay, the resultant of force PQ, the resultant of force P and Q must be in line with what? In line with force Q, force R, in line with force R is equal in magnitude of R and opposite direction, Did you get the point here? So from this point, from equilibrium principle of three forces, these are the three forces. The resultant of force P and Q, is which one? OC. That is OC must be in line with the third force. It is in line with the third force, and it is equal in magnitude, and it is in opposite direction. Okay. So now, as per the figure, this will be satisfied here. Now we'll go for the geometry here. According to figure, we'll go for the geometry. Okay. From the figure, from figure, now consider AOC, right? Angle AOC. What is angle AOC? Angle AOC equal to 180 minus beta. See here, this is AOC, beta is here, this is 180, this line is 180, right? This is 180, this 180 minus beta is angle AOC. Are you getting my point? This line is total 180. Now AOC is 180, total 180 minus beta, this one 180 minus beta, that is 180 minus beta here. This is A, that is AOC, this angle. Now come to the angle ACO. Can you tell that ACO? Angle ACO equal to this one, right? ACO is nothing but C angle COB, okay, like this, right? This will be equal to this. This is ACOB, right? ACOB. Angle ACO is equal to angle COB is equal to angle COB equal to 180 minus alpha. That is 180 minus alpha. How we will get 180 minus alpha here? COB. COB is nothing but this is 180 degree. This is 180 degree minus this is alpha. This is alpha. Whatever this angle you will getting here, it is 180, total 180 minus alpha here, right? This angle is 180 minus alpha, and this angle is 180 minus beta. This is minus beta and this is minus alpha. So that is the second one. Now angle CAO, this angle finished, this angle finished. Now come to the angle CAO. Only consider this triangle. I found one, first one is O angle, now C angle. Now come to the this angle CAO. Now angle CAO equal to, this is the one triangle, right? One triangle. So can I write it 180 minus angle ACO plus angle AOC. That is 180 minus angle ACO angle AOC plus angle ACO. Did you get the point here? CAO, this is one triangle. CAO, this is 180 minus this angle. Okay, this angle is ACO and this angle is AOC. Now this will be equal to 180 minus, so ACO is how much, AOC is how much, 180 minus beta plus ACO is how much, 180 minus alpha, 180 minus alpha here. Okay, now this will be 180 minus, how much you will get, 180 minus beta plus 180 minus alpha, right? Just simplify. Now, so how much you will get, 180 minus 180 plus beta minus 180 plus alpha, right? This will be equal to alpha plus beta minus 180. That is alpha plus beta minus 180. Alpha plus beta minus 180. That is angle CAO. Okay. Please just focus on these because we have to substitute later. Okay. Now come to, also we know that angle alpha plus beta plus gamma equal to 360. Right. The total 360. Also alpha plus beta plus gamma equal to 180. Will you agree? Okay. Now here alpha plus beta minus 180. I have to subtract on both sides 180 because I want to substitute angle CAO in this equation. If I want to substitute angle CAO in this equation, I need minus 180 here, right? So subtract 180 on both sides. That is alpha plus beta minus, subtract 180 on both sides. Okay, on both sides. Now I'll subtract here. That is alpha minus beta, alpha plus beta minus 180 plus gamma equal to 180 minus 180. Right? 180 minus 180. Alpha plus beta This is 360, right? Alpha plus beta plus gamma equal to 360. Sorry for this. Total angle is 360. Here 360. Here 360. Minus 180. Now substitute this value. How much is the value is? Angle CAO. Alpha plus beta minus gamma is angle CAO. Now I substitute angle CAO equal to 360 minus 180 is 180, and this will take in the right side. That is 180 minus gamma. 180 minus gamma here. Okay. So remember, one is O, this angle we want. One is C, this angle ACO, this angle, and one more is CAO. CAO is this. You just remember. We want to substitute further this one, and this one here. Okay, that is the condition. Now we know that from triangle AOC, OA divided by sine of angle, this is OA, which one is OA? OA divided by sine of angle is this one here, divided by sine of ACO, angle ACO equal to AC, this is AC, right? AC divided by sine of angle AOC, opposite to this one is AOC equal to OA finished, AC finished. Now OC divided by sine of which one is angle? This angle, that is OAC, OC divided by sine of angle CAO. CAO. This is CAO. Sorry for that. This is CAO. Okay. Now substitute the values of OA. OA is nothing but what is OA is nothing but P divided by sine of ACO. Just before I just erase this, we are just before we simplified. Okay. One sine of 180 minus how much? 180 minus alpha. That is 180 minus alpha. This we already simplified here. Equal to AC is nothing but OB. AC is nothing but OB. That is Q divided by sine of what? Sine of AOC. Just erase that, right? AOC is beta. 180 minus beta. AOC is nothing but this one, and this is 180 minus beta, right? That is 180 minus beta equal to OC. OC is nothing but what? OC is nothing but R. That is R. This is R divided by the sine of CAO. The sine of CAO is what? CAO is 180 minus gamma. 180 minus gamma. Okay. Now further simplify. We get here P divided by sine of 180 minus alpha is, what is the sine of 180 minus theta? Is sine of 180 sine of theta minus the all are positive. 180 minus all are positive. Sine and cosec, the 180 minus sine and cosec are positive, right? The positive here. That is sine alpha. This is equal to sine theta. Sine of alpha equal to Q divided by sine of beta equal to R divided by sine of gamma. Okay. So this is how the the Lami's theorem, it will be derived here. Okay, taking a parallelogram, and according to that construct the you will get a one more opposite the resultant force. Now only you have to consider the triangle ACO. Everything you have to done on that, on the basis of that alpha, beta and gamma here. Okay, you have to substitute, and finally you will get this derivation here. Okay.